Welcome back to Topic 40 for Algebra 2, Adding and Subtracting Rational Expressions. In Part 3, we're going to explore how to use rational expressions to solve a word problem. For example, Dominique drives her car to the mechanic, then she takes the MBTA back to her neighborhood. The average speed of the 10-mile trip is 15 miles per hour faster on the T. Find an expression for Dominique's total travel time. If she drove 30 miles per hour, how long did this take? So with this problem, we actually have two questions in one. So the first part that I'm really going to focus on is this part right here. Find an expression for Dominique's total travel time. Notice in this graphic that we have here, it gives us some interesting information about the distance, rate, and time for both a car and for the commuter rail for taking the T. So we can represent the time for a car by 10 divided by r. And we can represent the time for the commuter rail by 10 divided by r plus 15. So because we want to find the total travel time, these two fractions represent the time traveled for the car and the time traveled for the T. So the sum will be the total travel time. Our first fraction, we have 10 divided by r, and our second one, we have 10 divided by r plus 15. So these are two quantities that we have. But in order to simplify this, we need to get a least common multiple in the denominator. So our first factor that we're dealing with is r, and then the second one that we're dealing with is, let's do a different color, is r plus 15. So I'm going to multiply the first fraction, 10 divided by r, by r plus 15 in both the numerator and the denominator. Because remember, if we simplify it, it would simplify to 1, so it's not going to change the value of that fraction. The second fraction, I'm going to multiply r divided by r. Again, simplifies to 1. So if we were to rewrite this, our new denominator is going to be r times r plus 15. Now in the numerator, we can multiply and distribute. So we have 10 times r and 10 times 15, which gives us 10r plus 150. And we're adding that to 10 times r, or just 10r. Now we can combine our like terms and get our expression of 20r plus 150 divided by r times r plus 15. So that is the expression that we can use to show the total travel time for Dominique. Now in example number 2, I should say in problem number 2, we have the question, so if she drove 30 miles per hour, how long did this take? So what we're going to do here is we're going to plug in 30 in for r. This is the rate, and our rate is 30 miles per hour. So we can use this in our rational expression that we just identified. So we have 20r plus 150 divided by r times r plus 15. So if we plug 30 in for r, we will end up getting 20 times 30 plus 150 divided by 30 times 30 plus 15. So now we can simplify. We simplify the numerator. 20 times 30 gives us 600, plus 150 gives us 750. And if we look in our parentheses, 30 plus 15 gives us 45, times 30 gives us 1,350. So we have this fraction here. Now this simplifies to 5/9. And if we think back to our unit is 30 miles per hour. So this is going to be equivalent to 5/9 of an hour. But what does that actually mean in terms of minutes? How long will it actually take? So we can set up a proportion. So if we have 5/9 equals, and we know that there are 60 minutes an hour, we want to figure out how many minutes that would represent. We can cross multiply and get 5 times 60 equals 9 times x, and divide both sides by 9. So this will simplify to about 33.3 repeated minutes. So in other words, it will take Dominique approximately 33 minutes for this trip. And that is our example. Thank you for watching.